Hello, everybody, and welcome back to the Azure podcast. I'm your host, Evan Baslick. I'm joined by my fellow co-host, Sajid DeMello today. This is episode number 497. We're getting closer to that, 500, Sajid. We're recording this on June 11th, 2024. And our special guest today is Rishabh Tewari to talk about Sirius, aka Accelerated Connections, which is a new, high-speed connectivity option that we've released in Azure. But before we get into that, let's talk about news. So, G, looks like you got a couple of things out there. What do you want to talk about today?
Yeah, a couple of things. So first is when you use the API management portal, that's a fairly elaborate developer portal, right? You can set up endpoints, you can do authentications, you can do proxies and whatnot. And there wasn't really a good way to do an audit trail of all the changes that were made in that portal. A developer comes in, makes changes to some endpoint, and you want to know that was done. So now there's just audit logging in the Azure API Management Developer Portal, right? So you can specify any changes get audited and it'll get sent to a storage account or the usual like a log analytics workspace or an event hub, the usual destinations that we deal with in Azure Monitor. So I think like any sign in to the account portal, any API details that were viewed, any testing of APIs that was done, what was the output, all those things now get kind of audited. So that's I think that's a good feature to throw in there.
Mm-hmm.
And then another one is also related to log analytics. I think we all have gotten to love KQL, right? That's the
Mm-hmm.
language that is used to
Mm-hmm.
query log analytics. I mean, it's not a complicated query language, but for somebody who's new to Azure Monitor or just coming into the log analytics system, it's sometimes a little bit daunting. You have to learn this new syntax and whatnot. And so I'm happy to say that they are now announced a preview of what is known as the simple mode for log analytics. In simple mode, you don't need to know KQL, right? Kind of everything's driven through drop-down boxes or through filters, and it's just say click here, it
Oh,
gives you
okay.
a list of
Yeah.
filters,
Yeah.
and then you say I want this operator, and and then the pivot on this or whatever, and
And
you
it'll
kind of
build that
and
for
it'll
you
build
under the
that out
covers.
for you. So I think that's
Nice.
that's a real cool feature, especially if you're new, right?
Yep.
I think over time you'll probably be faster or better off knowing KQL, but at least somebody, a person, an admin who's new to the system, can get their log searches done. So, yeah, those are the
Does
two
that
updates.
expose the query that it generates after you're done as well, so you can learn from what you were
Right,
doing
right.
as
It
well?
kind of,
Okay.
I think it kind of
Great.
puts out the query for you there. Yep.
Awesome. Okay. Yeah, I love features like that because then you can sort of do what you need to do, but you still are able to learn from
Correct. You
what
can
you
take this
do,
query, you
right?
can save them, reuse
Yeah.
them later if you have to, things like that.
Yeah.
Yep.
Awesome. Okay. Great. Okay, cool. Well, so actually a short, slow news this week. This is sort of the post build. Everything came out over the last month, and now there's sort of this lull, especially as everybody's going into summer. So let's get over to accelerated connections. But first, Rashab, go ahead and you and I have worked with each other for a long, long time. I don't want to think how many years. Go ahead if you could introduce yourself and tell the audience what you do here at Microsoft.
Yeah. So hello. Thanks for giving me opportunity, Ivan and Sujit, to basically cover accelerated connection. So my name is Rishabh. I lead Azure Virtual Networking team, which is part of the broader SDN group we have. We basically own how virtual machines talk to each other, how they connect to on-prem, how we connect them to internet, all the other features like network security groups, private links. So it's all about how we connect the endpoints together in a secure, reliable way. And the accelerated connection feature which we have built is built on the similar lines on how do we make network even faster and bring maybe the fastest VM to Azure cloud. And that has been one of the key driving factor behind building the accelerated connection feature. So I'll pause there and see if there's any
Yeah, I
follow-ups.
mean, let's start out when we say accelerated connection, and we'll probably use the terms interchangeably today between that and Sirius because we talk about it sort of interchangeably in our public content and our documentation. Um, like like how do you what is an accelerated connection? Because I mean,
Yeah.
I've done lots of VMs over the years. I don't how do I know if I need this feature? Like, how do I
Sure.
know I should turn it on? Like, should I just always do it? Like accelerated networking in general, or like, how do I think about that?
So let me take a step back and go into why we even need something like accelerated connection. So when we started the journey on Sirius platform and towards the accelerated connection, one of the problem we were trying to solve was how do we make SDN ubiquitous, which is not just applicable to virtual machines, but also applicable to bare metal workloads like NetApp appliances, Cray supercomputers. How do we make the full SDN available to our on-prem customers? How do we accelerate SDN to the levels where we can go beyond what capabilities we can offer from a single Azure host? For example, a single Azure host, let's say, can serve X number of CPS and Y
You're
number of
talking
total
connections per second when you say
number of
CPS.
connections per
Yep.
second,
Okay.
or the total number of flows you can support for a given virtual machines. Let's say a single host we have can support, let's say, Y such flows. Now, some of our customers reached out and what they wanted was, how do I go beyond the limit of a single host? So no matter how fast we make our host, there is always that disaggregation angle where you can only create a virtual machine which is as fast as the host capabilities.
Right.
Even if you
Right.
take the full host, you can only
Right.
go as fast as the host can go. That's problem one we were trying to solve. The second problem we were trying to solve, as I said, was all of our SDN features were limited to virtual machines. If we wanted to give the same feature to the on-prem clients or want to give the same type of feature to our bare metal workloads, we were not able to do that. So that was the second driving factor. Was some of these network functions like L3, L4, routing and all, you need virtual machines and which act as a network virtual appliances, and then you try to do that. But some of these functions, you don't even need those virtual machines because you can do them purely on a smart switch or a smart NIC or on a DPU kind of form factor. So with these three key drivers in mind, what we decided was the investment we need to do is towards disaggregating SDN, which is basically have a compute where you basically host your virtual machines. It can be anywhere. It could be via bare metal. It could be on-prem, and have these network functions hosted on a fleet of disaggregated DPUs, which can be at anywhere in the data center. They could be sitting on your smart switch. They could be on a top of the rack. They could be on a T1, or they could be a dedicated rack of appliances. Now, with this disaggregated architecture, what we basically get is a VM is no longer limited by what a single host can offer, because we can tunnel these packets to the disaggregated fleet of Sirius appliances and get as much CPS as the customer needs, because the host where VM is located doesn't have to do the complicated policy processing for those Sirius VMs. It just have to do the tunnel action, which is a very simple action. Similarly, with the flows, you don't have to track those 5-tuple flows on each and every host for a Cirrus optimized virtual machines. Those flows are tracked on a disaggregated fleet of Sirius appliances. So the customers who basically are dealing with problems like, my NVA can only go this fast, I want a faster NVA, they can enable accelerated connection. Some customers who basically need simple L3, L4 ACLing or routing, they don't even need to basically deploy a VM. They can deploy something we refer to as floating NIC and then route all their traffic through that and just apply the network policies, which gives you cost benefit, gives you the superior performance. And I'll talk about the numbers and all as we go, but I'll take your question, Ivan, first.
Yeah. I mean, so when I first heard about this feature, like in my head, I had envisioned sort of where we started in the networking world, which is we had these physical devices that all the routing was programmed into, and that hit scalability things because you just can't put millions of nodes into that feature. And I sort of felt like, hey, we're going back to that, but what you've sort of done is you've taken that concept and then you've turned it into an appliance, which could be n number of resources underneath, so you can really scale as much as you want. And because it sounds like you're also deploying this appliance for individual customers, so now you're no longer gated by sort of the scalability of the entire data center or region. You're saying, hey, this customer has a need for this, and so it's fully dynamic. It's to them. It can scale up or scale down. So you sort of take the best of that old central model, which offloads the control plane and offloads some of that routing stuff, while bringing in the scalability and the flexibility of the cloud. Is that probably a better way to think about it than the on-premises model?
That's absolutely right. So these appliances, we have a fleet of these. These are all multi-tenant. We are able to scale them up.
Okay.
We are able to scale them up and down on demand. We only leverage it for scenarios where we have to exceed the host capabilities. So it's not that every packet is going through them. We have mechanisms to short circuit the appliance and let the packet flow directly after the appliance has done its job. So we have all of those things coming together, which basically make sure these appliances are not the bottleneck. We place them closer to the virtual machine so that they do not even cause the latency problems where you have to take a hop, which is somewhere very far from where your virtual machines are. In addition to that, we have also open sourced some of the SDN transformation in something we refer to as Sonic Dash. So we have a Dash community where we are getting industry innovation at a very, very fast rate. We are able to get SDN transformations, these DPUs, which can actually be deployed in our data center as either appliances or as smart switches. We are able to get them from our partners who are basically making sure that the APIs are Dash compliant, meet the behavioral model requirements we have. And that also gives us best of all worlds in a way where we are able to use the industry innovation at a much, much faster rate and also get great agility, because now we don't have to go and update each and every host for some of the new features in the past. So we are kind of getting into those modes, making sure that these appliances are not the bottleneck, and we basically do not end up creating hotspots or choke points in the network.
Rishabh, you mentioned a couple of terms, and I want to just clarify them for our listeners. You said things like SDN, and also you mentioned T1 at some point, right? And SDN, I think what it stands for, software-defined networking. Is that what it is? Can you explain why that's important for us here in Azure to use that sort of a system? And then you also mentioned like T1, which I think I know what T1 is, but I think many of our listeners may not know what a T1 is, at least. In the Azure terms, I know T1 used to talk about a T1 network at some point, but that's different.
Sure. So I think as we started with virtual networking as one of the building block of modern clouds, we want to make sure our customers are isolated, they are secure, and for that we need to make sure that the network is, while running the top of the same physical network, we basically create a software-defined network which provides the isolation between different customers. We also have all the traditional features which customers use on-prem, like ACL, routers, appliances, VTAPs, multicast, all of these, we bring it to Azure Cloud so that the customers can use Azure just like they were using on-prem, and they basically get the same richness, all the feature sets they need. So that's how the relevance of SDN is in this. As I mentioned about placing some of these Sirius appliances at switches, we have different level of switches in Azure, where the top of the rack, or T0, and then you have switches which are sitting above T0s. We refer to them as T1. And some of these are very strategically placed in the network, where if you can do some network function on a T0 or a T1, you basically, first of all, avoid some of the round trip delays. It's also a very convenient form factor for you to place for your on-prem traffic, for your edge traffic, for the traffic which is coming from bare metal. So getting the flexibility and the agility of a switch form factor is one of the next thing which we are looking into as part of the whole Cirrus and appliance program.
Yeah, and I think too, as a general rule, although there are certainly cases where this isn't completely true, but T0 is the top of rack switch, right? So that's what connects all the blades in a rack. T1 is going to be what connects multiple racks to each other, and then T2 is going to be what's going to connect sets of racks or clusters to each other, right? So that different clusters and different data centers can talk to them. And actually, Rishabh, I think at that point we get into like the regional network groups or regional network hubs, which we won't get into here, but that's sort of the next step down. So as you go T0, T1, T2.
That's helpful. Thank you. Yeah, and then the other kind of point of clarification I wanted to ask for is, last week we had we had the topic of Azure Boost, right, which we talked about, and Azure Boost sort of talked about accelerated IOPS, I think, right, is one of the things, and they use things like FPGAs to implement that. Is this a similar approach that you're taking, or is this like almost a similar thing in the networking space that's happening here?
So Azure Boost is the foundation on which we have built Azure, right? Basically, each and every Azure host has as a component either an FPGA or some sort of smart NIC, which is what we leverage for all the virtual networking, all the ACLing, routing, and all those things I talked about. So Azure Boost is the technology which we will use for each and every virtual machine. The Sirius and accelerated connection technology, which I talked about, is beyond virtual machines. In most of the scenarios we kind of target are beyond virtual machines. But even in virtual machine case, like I said, let's say Azure Boost can support X number of flows for a virtual machine, because we have to optimize Azure host for most of our customers. We cannot go and put a Azure Boost card on each machine, which caters to 0.1% of the customers, because that's not cost effective way of doing so. The way we kind of make sure that we optimize Azure for the right balance of networking power and cost is we target Azure Boost for virtual machines and cater to most of the customers with that. With Sirius, we handle the most demanding workloads, which you cannot handle on the host, because let's say some customer says, I need 10 million flows for my virtual machines, which is running 4 cores. We can do that with a
huge number of flows.
Yeah, and we can support that because we have a disaggregated fleet. And if you think from trying to support such a thing on a local host, in theory you can build such a DPU, but that doesn't make sense to build such a DPU. So that's one important thing to consider, that the boost and the accelerated connection, they coexist, they kind of complement each other. And most of the virtual networking features which I talked about, we implement on Boost. So we kind of have each and every thing which I talked about, like virtual networking, routing, ACLing, all of them are implemented there. The second thing is we want accelerated connections and Sirius, not just to enable virtual machines. For on-prem, these devices are in the path. There is basically no Azure host in those cases. These devices are in the path for bringing your bare metals into Azure, which is bringing your edge zones into Azure. And the other interesting thing which I talked about was, let's say you want to build a network function. You want to build a layer 3, layer 4 firewall, or you want to basically accelerate some of the things in existing NVAs, which already run on top of Azure. Let's say you want to have a functionality of hardware SSL termination or things like that. The concept of floating NIC lets you do that. The moment you create a NIC in Azure today, that NIC has no meaning without a virtual machine attached to it, because we don't really allocate it. But with accelerated connection, you can create a NIC, and that NIC can exist on its own. The moment you create that NIC, it comes alive. You can use that as a next hop and apply ACLs on top of it. You can use it for routing. You can use it for accelerating your NVAs in future. Like you can put that NIC in front of a F5 or a Azure firewall and accelerate those by doing SSL termination and things like that. So with this aggregation, we are going to a mode where NICs can exist without VMs, and they can complement all the VM technology, all the VM network technology we have, and give our customers massive scale in terms of flows, bandwidth, connections per second, and even some of these hardware offloads like SSL termination, things like that.
So this, I mean, conceptually, all this sounds really great. And when we talk about the scale is always, customers are amazing in that whatever level we give them, they always find some really good reason to go higher than that. And so love them for pushing us to do more and more. But let's talk some actual numbers. So if my memory is right, we support 1 million flows per host, which is 500,000 And a flow is one direction of a tuple, right? So if you're bidirectional, which most conversations are, you use up 2 flows. So you're functionally getting 500,000 connections on that machine at any one time. And I can't remember, I don't know if you know the connection per second, that we would see on a typical NVA, but like what does Sirius allow us to get to today? I mean, is it really 10 million flows? If so, I don't know that I want to debug that problem because that number just hurts my head. But like, is that like a real number that we've been able to achieve in some testing, and what kind of packet per second benefits are people seeing?
So when Sirius is running in accelerated connection mode for VMs, the bandwidth it can offer, it's equal to the bandwidth of the VM, because we can't go beyond what VM is allowed to send.
Right.
But the flows it can offer today, the maximum CPS queue we offer today with Sirius allows you to create 3 million flows, which is 3 million in each direction. So you can go up, right? So and the reason why we can do that, again, as I said, was it's a disaggregated fleet of appliances, and we can give that even for a 4-core VM, because the network is scaling independently of compute. In a traditional networking, what end up happening is people tie the flows in CPS to the VM sizes, because you are using the hardware on the host for doing that state management. It's not scalable for people to offer 4-core machines which can do millions of flows, because that just doesn't make sense from cost perspective. With Sirius, we are able to scale the network and compute independently. And the one extreme of it is, in Sirius, the NICs can exist without VMs, right? Which is where you basically just create a network interface, and then you can
truly
start
a virtual
routing
NIC
traffic through.
At that point. Truly a virtual NIC.
Truly a virtual NIC, right? So you bring up that and you put it in front of an express route circuit, and you get private link at 200, 300 gigs or whatever speeds customers need, because now these virtual NICs can scale independent of VM sizes, because they are not even attached to a VM. So we have tested scenarios where we are able to pump multiple TBPS of traffic through these floating NICs, providing our most demanding customers, whoever need that kind of private link capacity, they can actually come from on-prem through these NICs and get that kind of capacity. We have tested the flow scale, which I talked about. We have tested CPS, connection per second. Our highest queue offers 3 million connection per second. And some of these crazy numbers are possible because we are able to move very fast with the industry innovation, because we don't have to wait for updating the entire fleet before we can use the latest and the greatest hardware. The second thing which brings these kind of numbers possible is the power of disaggregation and scale out, because we don't have to worry about scaling up the host, we can scale it out.
Yeah, that I'm just, and again, this isn't something our customers necessarily have to do, but I just think about some of the work that you and I have done in the past. Like you're like, you can't even put these two, a normal VM and a accelerated connection scenario on the same chart. Like it's just tactically, like you can't even fit that. So wow, these numbers make my head hurt at some level in a good way. But wow.
So yeah, I mean, we published a paper on this. We published a paper on this as well in an STI. So I mean,
yeah, we'll share it. We'll share it after.
Interested, I can share that.
Yeah, for sure. We'll definitely and then there's a really good VFP article from a number of years ago from Daniel, right? Firestone was involved in. We'll share that as well, so people can ground themselves there.
Yeah, Rishabh, you've been talking a lot about how ISVs, maybe people putting, things like appliances and whatnot can take advantage of this. But what about customers? You see actual end customers taking advantage of this feature. What are some of the use cases or workloads that you're seeing for that?
Yeah, so there are multiple customers who are already using it. So I'll talk about some of the customer use cases, so you get an idea of like what kind of customers will need such a thing. So there are customers who want their NVAs to work faster, where their NVAs choke under load, or they can't really take that many connections per second, or need more flows. They are enabling accelerated connection to basically reduce the cost which they have to pay. To put things in perspective, in many cases where NVAs cannot meet need, people keep scaling up those NVAs. That increases the license cost, that increases the cost they have to pay on towards maintaining those VMs and all. So this provides them significant cost reduction. It also gives them much superior performance because the hardware which we're using for some of these accelerated connection scenarios have hardware accelerators which are able to do stuff much more efficiently. So that's one category of customers who are using. The second category, as I said, was on-prem customers coming to Azure, accessing, let's say, Azure storage. So if let's say you want Azure storage using a private link at 200 gigs, floating NIC is the solution today. That is how we are able to give people 200 gigs coming through on-prem. Without that, we didn't have a solution for that. The third category, we are using this disaggregated fleet of appliances. Now, these appliances have multiple generations. We have continuously evolving them. So some of the scenarios run on the older generation, some are running on the newer generation, but the concept remains the same. There are customers who want bare metal in Azure, like they have NetApp hardware appliances and they put those appliances in virtual networks. And when they try to access it, they need network security groups, they need user-defined route, they need VNet scale. These appliances and disaggregated floating NICs are helping in those scenarios as well. The fourth big use case is wherever customers want to put, let's say, network ACL on top of a storage account. So the way they do that today is they put a storage account behind a private link, and on the private link, they put a network security group or NSG. But the storage account is not really a VM. So for you to evaluate and enforce that NSG, you basically need a place where you can do so. So for many of these scenarios, which were not even possible with the current architecture we have, we are kind of evolving. And then these appliance investment also tie into some of the new features which we are going to release in Azure, which are related to scale, which are related to meeting some of the customer demands related to networking enhancement. So some of those will soon be released, and I think we will be leveraging these appliances in the backend.
We'll have you or those various teams back on when that stuff ships, and we can say, oh look, see, it's accelerated connections are under that. Yeah, well, no, this is great, Rishabh. I mean, the sort of laying out the use cases, right? Sounds like there's lots of opportunity for different customers. Again, it sounds like not everybody needs this, but the customer base that needs it, right? It's a key feature set. Anything else that we didn't hit on that you want to make sure to share with the audience about the feature / service?
So I think we kind of covered the high level architecture. We talked about the motivation and the key customer segment which needs it. In addition to that, this is something which is a core infrastructure for us. So in many cases, we just use these things in the backend without our customers noticing that these things exist. And I think the success for any networking product is we have to make sure that customer gets what they want and they don't even notice us. So as long as we are successful in that goal, I think this whole program is successful, and that's what we are trying to achieve. Like our customers get the bandwidth they need, they get the scale they need, they can connect or peer as many VNets they want, they can get as much as private link bandwidth they need. So whatever those goals are, whether it's a scale in terms of data path, whether it's a scale in terms of some of the control plane limitations on number of ACLs we can support, on things which we cannot do in Azure cloud, which we can do elsewhere. So some of those gaps, all of those investments are tied to our disaggregation and accelerated connection investments, and all of those things are coming together basically, and more features are lighting up.
You raised one last question that I hadn't thought of that I just remembered. So do I, as a customer, let's say I need this connection per second, or I need to peer, whatever the number of, however many VNets that I need to peer together, do I just go do my work and then under the covers, Azure will provision, an accelerated connection appliance because I hit some number of peered VNets, and then the next one I do, Azure deploys a accelerated connection or a Sirius appliance, or do I need to provision this service as a thing, and then I can then do these other things by somehow hooking it into that. Like, what does that provisioning / onboarding experience look like for a customer?
So the onboarding experience looks different from different use cases. Let's say some customer wants a network optimized VM SKU.
Yep.
That's basically one of the accelerated connection VM SKU. Then they really opt in because the CPS and the flow scale is tied to the VM. So if you, let's say you create
so I don't have to do anything
normal,
special to get, I just pick that VM SKU and I sort of have it under the covers.
Yeah, you just pick that VM SKU and you have it. Now, for the scenarios which are not tied to VM SKU, like let's say you want to peer 10,000 virtual network.
Yeah.
In that case, customer doesn't go and say, oh, give me accelerated connection. We just kind of take care of that in the backend.
Okay.
Similarly, for express route premium, which is like somebody wants to come 100 gigs over private link, they don't explicitly create anything. As part of the express route fast path experience, these things automatically light up. So VM is one of the scenarios which is explicit because that's how VMs are, right? You basically select what kind of VM you need. But some of these other scenarios which I talked about, they are just automatic. Like similarly for the bare metal example, which we discussed, if somebody is connecting to a bare metal and they want to do ACL and routes, they just put the ACLs and routes the way they put it on a normal VM. And Azure takes care of provisioning the appliances and all the circuitry in the backend without customer noticing or doing anything special.
Okay, so sort of tying this back to, because I think you mentioned it, Sujit mentioned it. There's a lot of similarities between this and the boost feature that we talked about on the show last week. To a large extent, you just go do what you want to do. You turn on a feature, or you leverage something. And if we need to use boost underneath to achieve that, or we need to use the accelerated connections feature underneath to do that, we're going to go ahead and do that. You're not having to go deploy accelerated connections as a resource. Like you would have to go deploy a VM or a storage account. It's just, we're just going to sort of do it under the covers as necessary to make you successful.
Yes.
Okay, great. Awesome.
And we are already doing this under the cover for many scenarios, like when customer create private link NSGs, when they do bare metal and all. Other than the VM, which is explicit, everything else is happening under the hood. And the technologies we use, they are also something which we can keep getting to the newer version of those without customer noticing or without any impact to the existing fleet.
Okay. Yeah.
Can I ask one more clarifying question, Rishabh? So, I was just remembering the name that you keep using the word accelerated connections. And I thought I remember we used to have accelerated networking in VMs. And I just looked up my VM just now, and I do see it says accelerated networking is enabled. Can you just, for our listeners, just clarify the difference between these two options? Because I think the word accelerated is confusing here.
Yeah, sure. So when you enable accelerated connection, you're basically leveraging our host networking stack, which is Azure Boost, as you know, for offloading the connection processing.
Wait, because I think you may have misspoken. I think you said accelerated connections there. I think what you meant was accelerated networking, right?
Yeah.
Sorry, okay. I think you misspoke. Okay.
So when you use accelerated networking, you are basically leveraging Azure Boost under the hood, and you're basically saying that all my packet processing moves to the dedicated hardware accelerators we have on each and every Azure host. The performance you get is tied to what the VM SKU offers, and it's still limited by what a single host can offer. But when you enable accelerated connection on top of accelerated networking, you also get the disaggregation benefits. So let's say before your 4-core VM was getting some number of CPS and flow scale, but you want to maybe 10x it without investing in more host cores or without upgrading your virtual machine. In addition to accelerated networking, you can also enable accelerated connection and select the SKU. Once you select that SKU, you will automatically be upgraded for your flow counts and CPS and other things. So that's basically how, and that's why I said Azure Boost is the foundation on which each and every Azure VM is running, and that is how it is going to be. And these two technologies coexist, they complement each other, and as accelerated connection has applicability way beyond virtual machine. In fact, most of our user scenarios are not VM scenarios. there are accelerated NVAs. Other than that, most of the scenarios which I talked about are floating NIC scenarios or a real virtual NIC where the NIC exists somewhere in Azure data center, and you just use it for routing, ACLing, or whatever else network functions you need to.
Perfect. Thank you. That explains it.
Okay, sounds great. Well, Rishabh, great to have you on. Thanks for coming on to talk about this. I'm sure we'll see more and more features and capabilities light up on this over time, and appreciate you coming on. Thanks. See you, folks.
Thank you.